Hey Math 1, I've got a new video for you over 7.4. My goal for this video is to pretty much just rehash what elimination method is and then give you guys some practice with some solid story problems, word problems. So, let's get to it. Our first example, we're just going through the procedure of what are we supposed to do if we have a system and we want to solve it using elimination. Well, the idea again is I want either the x's to be the same, one negative, one positive, or the y's to be the same. Now this can be achieved instantly by multiplying the top equation by -2. Multiplying the top equation by -2 gives me positive 12x, okay? Positive 12x, positive 2y, right? The whole purpose of it was to create a positive that goes along with the negative 2y here, and then it should equal -78. The bottom equation, you don't need to do anything with it because we've got the -2y. All right, once you have this set up, now you can add the columns. The purpose of adding the columns is that it eliminates one of the variables if you've got identicals in which one's positive, one's negative. This will be 9x on the left and -63 on the right. Divide out the 9 and you get x equals -7. Okay? Plug that x equals -7 into one of the two original equations. It does not matter which one. So I'm just going to pick the bottom one. -3x minus 2y is equal to 15. That -7 is going in right here for the x equals, and then that'll be positive 21 minus 2y equals 15. Subtract the 21 and then divide by -2. So your final answer is going to be x equals -7, y equals positive 3. Okay? -7, 3. Which incidentally happened to be the answer to one of our mini quiz problems, right? Number 2. All right, this one requires a little bit of legwork before we can jump into full elimination mode. What I mean by that is I want to line up everything. So the first thing I can do with the right-hand equation is I can rewrite it as 6x minus 2y is equal to 4 using the symmetric property, okay? And then I can use the commutative property on number 2. Hold on. I think I need to take this heavy jacket off. There we go. -3x plus y equals 6. So notice there's a very distinct difference between what I did down here and what I did up here. Up here is the symmetric property. It was just a rewrite, the left and right equations, left-hand sides and right-hand sides just swapped. Down here, I use the commutative property to just rearrange the left-hand side. So, all right. Elimination states I need to get either the y's the same or the x's the same. Look, if I multiply the bottom by 2, that's going to create a positive 2y to tag along with the -2y. So, I'm going to go along with that. -6x plus 2y equals 12. And then I can just rewrite the top equation underneath that. It doesn't matter which equation is placed where. At this point, I've got opposites to get rid of the y values, but I also have opposites that gets rid of the x values. So I'm left with no variables at all. If both variables drop out, you have to read the situation. The situation reads a false statement. Since 0 does not equal 16, this is a no solution situation. These are parallel lines. All right, so hopefully that was helpful for just giving you guys a good warm-up on elimination method. Now to the word problems. So number 3. If you take 7 times a number and subtract 3 times another number, the result is 140. Oh boy. So, if you take 7 times a number, so let's just call that first number x, and subtract 3 times another number, we'll call that one y, the result is, it equals 140. Okay, nothing really special about that. Additionally, if the sum of those two numbers is 40, what are the two numbers? So sum means add the two together. So unknown number 1 plus unknown number 2 equals 40. All right, so we're just making sure you guys can create from maybe, sorry, you couldn't see the whole thing. Just being able to create that equation from, standard English, yeah? So now, ask yourself, which of these seems most convenient to work with? Well, the thing that jumps out at me is that we've already got a negative plus situation here, and if I multiply the bottom by 3, that's going to create a 3y here. The 3y with the negative 3y is going to instantly cancel out that y value. So, I'm just going to write 3x plus 3y equals, so 3x, 3y, equals 120. Yeah, and again, I'm just going to rewrite it directly underneath it. At this point, opposites, we want to add to cancel them out. So add here, add there, add all 3 columns. So then these cancel. This is going to be 10x, and this is going to be 260. Dividing both sides by 10 leaves me with 26 for the x. At which point you pick which one's going to be the most convenient equation to work with. Well, this bottom one, you could almost do that math in your head, right? 26 plus what equals 40? It's 14. So, don't be hesitant to just do a mental calculation like that if you're like, it's as simple as 40 minus 26. But this is what you would do to determine what those two unknown numbers are. Seems simple enough. Let's check out number 4. Let's make sure we have this whole thing in the picture. Okay, we got it. So in this particular situation, you got 2 guys who are selling fruit for a school fundraiser. Customers can buy boxes of oranges and boxes of apples. We got, looks like we're going to have a Matt equation and we're going to have a Mark equation. Kind of reminds me of the word problem where it was Alberto and we had Sal, and it's sort of like each of them had their own equation, right? So Matt sold 3 boxes of oranges and 14 boxes of apples for a total of $203. Okay, so we can make this relatively simple. 3 boxes of oranges. So instead of using O and A, I'm going to just use X and Y. 3 boxes of oranges plus 14 boxes of apples is going to equal $203. So right away, it's sort of like the number of boxes of oranges times how much they cost, plus the number of boxes of apples times how much they cost, is going to equal a total cost of $203. So we should say that X equals the cost per box of oranges, and then Y is going to be the cost of box per apples. Okay. So then Mark, he sold 11 boxes of oranges and 11 boxes of apples. All right, oranges X, apples Y, and that yielded $220. And they just want to know, how much does it cost per box of apples and per box of oranges? So we've got our system of equations here. Now, unfortunately, there's not a nice, neat multiply one equation by a specific number, and the whole thing will break down from there. What we have to do is we have to say, either make these x numbers both the same or make these y numbers. I'm gonna work with the x's because they're smaller. Looks like 33 is going to be the smallest number that divides both 3 and 11. So I want to create one of them as positive 33. I'll just make that the top one. So multiply by 11. But I want to make the bottom negative 33x. So I'm going to multiply that one by negative 3. All right, so you guys see what I did here? I now have 33x for the top equation, negative 33x for the bottom. All right, so 11 times 3x is 33x. 11 times 14y is, this is where using the calculator will ease that burden of calculation so so that you guys don't make nitpicky mistakes. At any rate, this is 154y. And then 203 times 11 would be, maybe I should check out the calculator on these. If I can find one. Okay. 11 times 203. Yeah, 2,233. All right, and then the bottom, negative 33x minus 33y equals negative 660. That one was easy enough where we didn't need to use a calculator. Okay, at this point we add all the columns. Add this one, add that one, add the last one. The x's cancel, so now we are solving for the cost per box of apples. So this gives us 121y. You know what? I'm just going to make this quick. 1,573. And then divide that by 121. 13. So there are 13 costs, so this would be dollars. $13 per box of apples. Now, how much do the oranges cost? Well, you plug y equals 13 into one of the originals. I'm liking the bottom one here. I don't know why. I'm just going to plug into this bottom equation. 11x plus 11y is equal to 220. So 11x plus 13 times 11 would be 141. Let's double check that. 143. My bad. And that equals 220. Subtract the 143 and divide by 11. The answer is 7. So if x equals 7, that means the oranges are $7 per box. And there's our final answer. All right, last one. The admission fee at a small fair is $1.50 for kids, $4 for adults. On a certain day, 2,200 people enter the fair and $5,050 is collected. Use a linear system to determine how many kids and how many adults attended. So right away, let's just make X be the number of children who attended, and let's let Y be the number of adults who attended. So now we're going to have two equations here. One that's going to represent the just people, and one that's going to represent the money made. So it's kind of like the people equation. You can think of it like this. You literally only have children or adults. The number of children plus the number of adults who attended has to equal 2,200. The number of children X plus the number of adults Y. It can't be anything other than 2,200. So sometimes like the people equation, or I think you guys saw it on a previous video, the one with the tables and a certain limit per customer base. Right, it's like X plus Y equals that total number. Now in order to get money, you multiply a person times $1.50 if it's a kid. A person times $4 if it's an adult, as far as the money you bring in from the people coming into the fair. So that second equation is going to be, for every child, I get $1.50. For every adult, I get $4. And the total? $5,050. At which point we've got our equation. I'm not sure which is easier to multiply by, the 1.5 or the 4. Probably the 4, right? So here's what I'm going to do. I'm going to create, I have a plus 4y, I'm going to create a negative 4y right there. So I'm going to multiply by negative 4 and then just drop it below here. So negative 4x minus 4y equals negative 8,800 if I multiply negative 4 times 2,200. Now we're all primed to get rid of the y's, so let's add those columns. This ends up being negative 2.5x. Again, if you're still kind of spotty with those decimals, at this point you can just use a calculator to check it out. Same thing with bigger numbers like negative 8,800 plus 5,050. And then you can divide by negative 2.5. A negative over a negative is going to be a positive value. So it appears that we had 1,500 X's, 1,500 children at the fair. Right, and then with the adults, it has to add up to 2,200. So 1,500 plus y has to equal 2,200. Subtract that 1,500 from both sides. Y equals 700. So there's 700 kids. I'm sorry, 1,500 kids and 700 adults. All right, guys, so word problems, yeah, they can be tricky at times, but I think you guys will see that there's not too big of a jump for you guys to be able to watch these and do it on your own. So, thanks for watching. Good luck on 7.4.